Right. MCQ number 1. 2A plus B goes to 2D is a single step reaction. Okay, now that is a single step reaction. That means it's a elementary reaction, right? That is an elementary reaction. So you can write R equals K times concentration of A to the power 2 times concentration of B. For given concentrations of A and B, the rate of the reaction is equal to R. That means that initially the rate is R. When the concentrations of A and B are doubled, the rate of the reaction may be, right? Then let's say R2 equals K times, now if it is double, then it is 2A. And this is 2B. Then you can divide 1 and 2. 1 divided by 2, that is R over R2, divided by concentration of A squared, concentration of B, 2 squared is 4. 4 times concentration of A squared, and this one 2 times concentration of B. This one cancel off, this one cancel off. So therefore R2 will be pointed to 8 times R. So that is answer number 3. This is 2000 A level question number 14. Answer number 3. Write it down quickly. Then people, next on second one, the rate of the reaction SO2 plus O2 can be increased by introducing NO into the reaction mixture. Now this reaction SO2 plus O2 can be increased by adding NO2. Why is that? Because it acts as a catalyst. So how do you know this? Now this is 2000 A levels. So in their syllabus at that time, this might be there. But the idea is that in kinetics, now NO acts as a catalyst in this case. So the mechanism is changed. The mechanism of the reaction between SO2 gas and O2 gas is modified in the presence of SO. I think this is there in the resource book under kinetics as a reaction, as an example. They have given this as I remember. So the answer is answer number 1 for this. It explains the first one. The rate is increased by the action of catalyst. And why does it increase? Because the mechanism is modified. You can see that the mechanism is modified. It provides a new activation barrier with lower activation barrier. So those are the reasons. So the main reason is the mechanism is modified, and that is correct. So answer is answer number 1 for the second one. Answer is answer number 1 for the second one. I'm lagging. Now okay, right? They have done it. Hurry. Then the third one. The rate determining step in a certain reaction has been found out to be 2x goes to y plus z when the concentration of x is 0.6. So the rate determining step of a multi-step reaction is this, y plus z. When the concentration of X is 0.6, the rate of the reaction is R. Okay. Therefore, when the concentration of X is 0.12, the rate of the reaction in mole per cubic. Now, this is R equals K times concentration of X squared. Ne? So that means you are doubling the concentration, just like the previous one. R2 equals K times 4 into concentration of X squared. මෙතන 4 දැම්මේ 2 squared වෙන හින්දා 2x නේ. අයියෝ කියලා පෙන්නන්නම්කෝ, otherwise you won't understand. 2x squared. 2 squared is 4 නේ. R2 equals K times 4 into concentration of X squared. Now I don't put the concentrations because it's the same thing, right? They are doubling the concentration. You can see 0.6 multiplied by oops. It's not like that. It is not multiplied, ne? 0.6 times 2 is 1.2, ne? Yeah. That means we have to substitute the values. We have to substitute and see. R equals K times concentration of X squared, ne? Initially. That means this one becomes 0.6. Right? 0.6. Rate of the reaction is R, okay? Then R2 is R times K times concentration 0.12, right? 0.12 squared. So now you can divide this by this. R divided by R2, R divided by R2 equals 0.6 over 0.12 whole thing squared. This is 1.2 10 to the power minus 1. 1.2 10 to the power minus 1. So that means this one is going to be actually 0.1. 0.2. 0.2. This is 0.2. That means this is 5. R over R2 equals 5. 5 squared is 25. Is it like that? (0.6 over 1.2 10 to the power minus 1). This is twice. 10 divided by 2 is 5. 5 squared is 25. R2 equals R over 25. Then okay, ne? 0.4. That's gonna be answer number 3. Answer number 3. 2001, question number 25. Answer number 3. Then next one, fourth one. Experimental data regarding a certain reaction relevant to the reactants P and Q obtained at temperature 353 Kelvin is given below. Hurry. They have changed the concentration of P and Q accordingly, you can see, and the initial rate they have given. The relevant rate equation, now this is a, experimental based question. That means you can see when keeping P constant and doubling Q, it is like almost doubling the rate also. So that means the order with respect to Q should be 1. That means you can eliminate answer number 1. Answer number 4. Answer number 1 and 4 you can eliminate. Then when you keep Q constant and you double P, when you keep Q constant and double P, double you like half it, right? However, 1.74 times maybe we have to do that, calculate and see. However, Q is 1. Q is 1 because it is like doubled. You can see that 1.74 times 2. Ne? The rate is also double. When Q is double, rate is also double. The other one we can see 3.2 divided by 1.6 to the power x, let's say, is equal to 1.7 10 to the power minus 5 divided by 87.0, 0.8 down, 0.87 into 10 to the power minus 5. This is also approximately twice, right? 0.8 times 2 is 1.6 ne 0.87 is approximately twice. 2 to the power x equal to x equals 1. Both are 1 ne. Both are 1 kyanne people. Oops, there is a problem with the question. It's answer 3 or 5. I'll check and tell you. There's a problem with the typing thing. Wait. This is 2002, right? 2002, 24. 2002, 24. It should be answer number. අඩ ඒකෙත් පේන්නේ නැහැ කියපන්කෝ. I think answer නේ මන් දන්නේ English medium paper එක පේන්නේ නැහැ. I'll go to the single medium. I hope you have done these questions. Like you have to do these questions. $2,000 kill 2 නේ. 24th one. First answer is proportional to P. Second one is proportional to Q. Third answer is proportional to P and Q. Fourth one, P and Q squared. Fifth one is P squared Q. Fifth one is P squared and Q. So the answer should be answer number 3 then. Answer is answer number 3. Answer is answer number 3. Guys, am I lagging or something? Am I lagging? Right now, am I lagging? No, ne? Okay. I'm going to erase the board. Fifth question, next one. Which of the following is not a characteristic of catalyst? This is unimportant. First one, catalysts are chemically unchanged, correct? Catalysts are specific in action, that is correct. They are sometimes specific in action. Catalysts reduce because one catalyst for one reaction does not catalyze another reaction, so it is specific in action. Catalysts reduce the enthalpy, that is wrong. Catalysts provide an alternative route for a reaction. Catalysts lower the activation barrier of a reaction. Now, the thing is, this is 2002 A levels. Back then, they took it as correct. Lowering the activation energy, they took it as correct. But now in the new syllabus, you cannot take it as correct. If you check the marking scheme, they have given only answer number 3. But I will give answer number 3 and 5 for this question, because in the new syllabus, we have to consider it as wrong. So 3 and 5 both, you can take as answers. In the new syllabus, catalyst cannot lower the activation energy. Catalyst only creates a new pathway with lower activation barrier. I hope you understood that when I was teaching chemical kinetics back then. So yeah, that's it. Then sixth one, 1 gram of uniformly powdered calcium carbonate was reacted with 100 cubic centimeters of, then there's a reaction. When the volume of carbon dioxide was plotted against time, then you get this graph. Part A, the rate at which CO2 liberated decreases with time. That is correct. You can see it is like reducing with time. The gradient is reducing. So that is correct. B, approximately 6 minutes after starting the reaction, an equilibrium is reached. It is not an equilibrium, ne? No. That is not equilibrium. This is not an equilibrium reaction. This is not a reversible reaction. B is wrong. C, rate at which CO2 liberated increases with time. That is also wrong. D, approximately 6 minutes after starting the reaction, the concentration of different species present in the solution becomes constant. That is correct. They have not given any information regarding like this is a reversible reaction. For sure, calcium carbonate and HCl reacting together is not a reversible reaction at room temperature. So that means, yeah, A and D answer number 4. They're asking the correct ones, mate. A and D answer number 4. Seventh one, the rate of a reaction consisting of several steps is determined by the step with the lowest activation energy. No, the rate of a reaction, I told you, like when people are working, two people working together, the person who is working the slowest will determine the time taken to build that building. Kinetics ugannathi give example. I told you, like taking a brick and going here and giving it to another person. Likewise, the person who is walking slowly will determine the rate of the reaction. He will only determine the rate of the reaction, not the other person who is like running fast here and there. So that means step with the lowest activation energy. So the slowest step will determine slowest step will determine the rate. Slowest step can be one with the highest activation energy. The one with the highest activation energy will be the slowest step. That means it is not the lowest activation energy. Lowest activation energy is the fastest one. So that is wrong. Second one, at a given temperature, the rate of a reaction with a low activation energy will always be faster than another reaction with a high activation energy. That is correct. Answer number 4. First one wrong, second one correct. Eighth one, in industries, catalysts are used to get more products from a given amount of reactants. No. In catalyst doesn't. Now, it's like this. You have a Mari biscuit, you put some catalyst in it, and Mari biscuit suddenly becomes 2 Mari biscuits. Well, that is like godly thing. Ne? It won't happen. In industries, catalysts are used to get more products from given amount of reactants in a given. That is wrong. How is it? In a given time. In a given time. In a given time, තිබත් හරි. Be careful, people. I didn't see the in a given time. මෙහෙමනේ. More products from a given amount of reactants. හරිද? Same reactants make within a given time කිව්වොත් අවුලක් නැහැ. එතකොට නම් හරි. Catalyst increases the rate නේ, so more products can be obtained within a given time. ඔය within a given time කියලා තිබ්බ එක නැත්තම් then this statement is wrong. හරිද? ඒ කියන්නේ I told you, if you had 1 Mari biscuit, you put a catalyst there and you get 2 Mari biscuits. It's not like that. Right? Within a given time is correct. That is correct. Then second one, good catalyst does not catalyze the reverse reaction. No, people. The thing is, catalyst will decrease the activation energy. Catalyst will decrease the activation energy. When it decreases activation energy, it will actually catalyze the forward and the backward reaction both. ඒ කියන්නේ activation energy අඩු කරා කියන්නේ reverse reaction එකයි forward reaction එකයි දෙකම අඩු වෙනවානේ සාමාන්‍යයෙන්. ඒතකොට ඒ statement එක it's not very good. ඒ කියන්නේ වැරදි කියලා හිතනවා. It's like wrong. So first statement correct, second statement wrong. Answer number 3. Answer number 3. Try 9th and 10th one. Try 9th and 10th one on your own. I'll give you 2 minutes. 2 minutes, huh? Only 2 minutes. Try them. Yeah, catalyst will not reduce activation energy. People, one more thing. I missed it. 7th question, maker. 7th එකේ first statement එක අවුලක් නෑ, lowest activation energy. Second statement එක at a given temperature, rate of the reaction with low activation energy will always be faster. Now, always be faster කියන්නත් බැයිද? Usually when the activation energy is lower, the rate of the reaction will be fast. But what about other conditions like temperature and then such kind of things which will slow the reaction? ඒවත් තියෙන්න ඕනේ. Now there are 3 needs which you have to fulfill in order to make a reaction happen according to the collision theory. They should collide with proper orientation, they should have enough energy than the activation energy to react. Those three conditions should be there. ඉතින් අර lower activation energy එක විතරක් අරගෙන like it's fast කියන්නත් බෑ. I'll take it as answer number 5. If you have put answer number 4 and you have put it correct, put it as wrong, it is answer number 5. Seventh and answer number 5. Right. Ninth one I'll do now. Are you done? The reaction NO plus and 2H2 gas, blah, 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 is a second order reaction with respect to NO gas. And a first order reaction with respect to H2 gas. Under certain reaction conditions, 1 mole of NO was allowed to react with 1 mole of H2 gas. The rate of formation, we have to draw a rice chart now. NO plus 2H2 gas. මේ plus එකක් දැම්මේ කවුද? There is no plus here. Nitrogen gas plus 2H2O. 1 mole of NO and 1 mole of H2 gas was allowed to react with 1 mole of H2 gas. The rate of formation of N2 gas initially was 0.02 mole per second. In 1 second, in 1 second, I'm going to fill the rice chart in one again. I'm not going to fill the rice chart in 1 second again. Mama 1 second වලින් මේක ලියනවා කියලා නෙමෙයි කියන්නේ. In 1 second, how many will be reacted, how many will be formed? That's what I'm going to write. So nitrogen formed amount 0.02 plus 0.02. Then this will be 0.04. This one consuming is like 1 is to 2. This is minus 0.04. This is also minus 0.04. Right. Then they're asking under these conditions, part A, the rate of reaction of H2 gas is 0.02 mole per second. Rate of reaction of H2 gas is 0. No, that is wrong. That is wrong. Part B, the rate of reaction of NO gas is 0.04. That is correct. This is correct. The rate of reaction of H2 gas is 0.04. That is correct. B, C correct. Rate of reaction of NO gas is 0.02. That is wrong. B and C correct. That is answer number 2. Actually, giving this doesn't make any sense now. You don't need it. අර අපි kinetics ඉගෙන ගත්ත මුල් කාලේ අපි use කරන the rate of formation of one compound, we can find others. Likewise, there we didn't discuss about these rate laws and stuff, right? We don't need them. Tenth one, what did you get? 2004 51. 51 become 51. අරක 51 නෙමෙයිනේ. මේක 2003 වෙන්න ඇති. I can't find people. Both are 51 කියලා දීලා තියෙන්නේ. Maybe that's 41 ද නෝද? නෝනේ. I'm just searching the question number. දැන් 51 කියලා දෙකක් තියෙනවා. So in case if you want to look at a review or something, you have to know the question number නේ. Okay, let's not care about it නේ. I'll find that later and tell. 10th one, underline 9th one. I'll search that and tell. In a reaction consisting of several elementary steps, the step with the highest activation energy is the slowest step. That is correct. Part 2 there. Reactions with different activation energies cannot have same rate. Reactions with different activation energies cannot have same rate කියන එකත් වැරදි. They sometimes can have the same rate. Just because it has the different activation energies doesn't mean it cannot have the same rate. එක සමහරවිට තියෙන්නත් පුළුවන් according to temperature conditions and then concentrations. Likewise, we can make them equal. So that means it is not correct. Only A is correct. Answer number 3. 11, 12, 13, 14, 15. Do them. 11, 12, 13, 14, 15. So these are statement type questions. Quickly you can do. 16 also do. 17 also you can do. That's a statement type question. All these questions, statement type questions. Quickly do. Mostly people kinetics, you are getting statement type questions. Mostly. Sometimes there can be calculations also. Mostly you are getting statement type questions. Okay, 11th one. Rate of a chemical reaction occurring at constant temperature decreases as the reaction continues because important. මේ වගේ questions review කරන්න, right? You have to review these kind of questions. These statement questions are very important, people. They are going to repeat these statements. Definitely, for sure, they will repeat. it feels so good to know these things. I mean, don't you feel like that? Like when the rating, how does the catalyst decreases activation energy? If you know that thing, people, don't you feel good? Something like as science students, as people who are doing chemistry, අර ආසාවෙන් නම් කරන්න. If you are doing this with, I mean, if you like this thing, if you know these concepts, you will start to feel some good thing within you. If you like understand, again, අර මේකට කැමති නම් A level මේ chemistry, physics, if you like these things, and if you get to know such a thing like this, and then you will feel good. හරිද? feel එක නැත්තම් ඉතින් ඒක ප්‍රශ්නයක් එතන. හරිද? That means you are doing a field which you don't like. So that is a bad thing. Because one day when you go into the outside world by doing these things, you will one day feel, I don't know. It's hard to tell, like, කැමති නැති දෙයක් කරන්න අමාරු people. When you are going to a job every day morning and you scold everyone, you scold the owner of the company and stuff, and then you scold everyone around when you walk in the road. අර පට්ට එපා වෙලානේ යන්නේ. If you do something which you like in future, then you will love every day. Every day you will be craving to go to your job. යන්න ඒ වගේ vibe එකක් තියෙන job එකක් කරන්න. But doing bio and doing maths in A levels gives you a lot of opportunities in future. You can do anything you want. It's not only medicine and engineering. There are many highly paid jobs than them in this world. So there are many open fields. Everything is there. You can go and explore after you write your exams. There are like 4 or 5 months until your results come. You can explore very carefully and then apply to university. Right? Within that 4 months, I tell you to have a good search. Not only medicine and engineering. There are many other fields which are like many other fields are there. I can't explain that all that. I'll later explain after you write your exam by taking a meeting or something. Right? Let's see then. Right. Rate of a chemical reaction occurring at constant temperature decreases as the reaction continues because occurring at constant temperature decreases. Rate of chemical reaction occurring at constant temperature decreases. අයියක අඩු වෙන්නේ people? Without looking at the 5 answers, just tell me why is it reducing? Can someone tell me why is the rate reducing? ටිකක් කළා ගියාම rate එක අඩු වෙන්නේ ඇයි? Because, yeah, the concentration is reduced. The concentration is reduced with time as the reaction progresses. Therefore, the rate will decrease. එතකොට මේකේ කියනවා fifth one look කියලා enthalpy change. No, nothing will happen to that. Fourth one, concentrations of reactants decrease with time. That's the proper answer. Third one, activation energy, no. Second one, rates of forward reaction, no. The percentage of reactant molecules having energy excess of the activation energy decreases. That's a good answer. Concentrations of reactants decrease with time is okay. Percentage of reactant molecules having energy in excess of the activation energy decrease, that is way more correct. That is way more correct. ඒක පට්ට හරි. ඒ කියන්නේ අර now when you take a MCQ paper, A level paper, just read on top part, they will say select the most appropriate answer. හරිද? එතකොට the best answer here is answer number 1. Percentage of reactant molecules having energy in excess of the activation energy decreases. එතකොට ඒකේ answer එක I'm going for answer number 1 for that. Concentration of reactants decrease with time එකත් හරි, but අරක it's like way more correct because this reaction is happening at constant temperature. That is way more correct. Then what did you put for the second one? Can people? එහෙම කියන්නත් පුළුවන් නේ. That's a valid point. Percentage of reactant molecules having energy in excess of the activation energy decreases. Concentrations of reactants decrease with time. ඒකත් හරි ඉතින් නේ. Now one person has put answer number 4 and she's arguing for that. If I were you, I would also go for the fourth one here. Having energy in excess of the that looks way more correct for me. Wait, let me check. Yeah, you took answer for me. Mm, wait. Keep doing the other questions. Yeah, I think correct thing එහෙම බැලුවොත් ඉතින්. Mm, mm, mm. Okay, then go for answer 4. That one. Yeah. Rate of a reaction occurring at a constant temperature decreases as the reaction continues. Because percentage of reactant molecules having energy in excess of the activation energy decreases. ඒකේ percentage එකක් අඩු වෙන්නේ නැහැ නේද? I didn't say that. Look. ඒක එහෙම කියන්නත් බෑ ඉතින්. I don't know, people. I think it's unfair to not put answer 1 also for that. I'll go with answer 4, but at the back of the mind, I am arguing for answer number 1 also. On one hand, I'm arguing for answer number 1 also. Because it looks correct. There's no error with that. Percentage of reactant molecules having energy in excess of the activation energy decreases. Because the molecules which have energy greater than the activation energy will react in people, they will react to form products. So the remaining ones do not react. The remaining ones do not react. එහෙම බැලුවොත් ඉතින් මේ දෙකම හරි ලයින් එකක් තියෙනවා. But in the marking scheme they have given us what is the taking for again? What is the ailment? I didn't understand. Ailment Sachini, I didn't understand what you told. Okay, let's see 12th one. The rate of an exothermic reaction increases with temperature. Rate of all reactions increase with temperature. Exothermic වෙන්නත් පුළුවන්, endothermic වෙන්නත් පුළුවන්. Second one, the fraction of molecules with energy above a certain value increases with temperature. එක හරි. එතකොට answer is answer number 1 for that. 12 answer number 1. 13th one, the rate of a chemical reaction increases when the concentration of reactants are increased at a constant temperature. Now people, concentration of reactants are increased. at a constant temperature. Now the concentrations are increased and they're asking what happens to rate. What happens to rate කියලා දන්නවා මේ කොහොමද වැටෙන්නේ කියලා තමයි අහන්නේ. First on number of collisions between molecules increases. ඒක හරි. Number of collisions increases. Fraction of molecules with energy in excess of the activation energy increase. නෑ. Fraction මම කිව්වා chemical kinetics last page I gave you this note. Fraction of molecules doesn't change. Energy of the collisions increases. No. D. Fraction of molecules with the correct geometry increases. එහෙම ගත්තොත් ඒකත් correct geometry කියන්නේ අර මං කිව්වේ the proper orientation like මෙහෙම ගමුකෝ මෙහෙම එක්කුයි තියෙනවා. So when they collide like this only they are going to set together නේ. Now they will set together. But if they collide like this they will not set together නේ. They will just bump off each other නේ. එතකොට ඒක මොකක්ද කියන්නේ? Is statement 1 wrong or correct? මම ඒක wrong කියලා ගන්නවා ඉතින්නේ. හරිද? හරි. එතකොට මේක බලන්න. If they collide like this they will form the product නේ. If they collide like this they will not form any product. කියන්නේ බම්ප් වෙලා යනවා. එතකොට අර correct geometric fraction එක වැඩි වෙන්නේ නැහැ. amount එක වැඩි වෙනවා. දැන් fraction එක කියන්නේ numerator එකට මම දානවා with proper geometry. Proper geometry කියන්නේ proper orientation. Proper geometry යටින් දානවා total molecules. When you increase concentration, what happens is proper geometry increases and total also increases. So it doesn't have any effect on the fraction. That is wrong. First one correct, second one wrong, third one wrong, fourth one wrong. Answer is answer number 5. 13th one answer number 5 because of that. Did you understand? Rehashi Suresh. Okay. Fourteenth one, under a given set of conditions, the catalyst increases the amount of product obtained in a unit time. Mega hari. Catalyst alters the enthalpy of a reaction. Catalyst alters the enthalpy of a reaction. That is wrong. 14th one, easy answer number 3. 15th one, two different reactions taking place at the same rate, at the same temperature, should have the same activation energy. Two different reactions taking place at same rate, at the same temperature, should have same activation energy. No, the concentrations can vary. The concentrations can vary. Last point QA, which one? Which question? 13th one. 13th one, part D. I keep on Q1. Proper orientation. Lollipop and one lollipop and one U-shaped thing like this. If they collide in proper orientation, they will form a product. If not, they will just bounce off with each other. So I told you in the numerator, you have the amount of molecules with proper geometry. Proper geometry can correct orientation. At the bottom, you have total amount of molecules. When you increase the concentration, what happens is proper geometry will also increase. Total will also increase. Again, both sides will increase. So numerator and denominator both increase. Doesn't mean the fraction doesn't increase. It will stay constant. right? Numerator increase, denominator will also increase by the same amount. Hari, right? Yeah. Then the 15th one. Two different reactions taking place at the same rate at the same temperature should have the same activation energy. මේ වගේම කලින් statement එකකුත් තිබ්බ නේද? Something similar to this. Something similar to this we had before. In that one, people, they didn't say about temperature. They only said about activation energy and asked you whether they are equal. Now they have given temperature also same, activation energy also same. Then they're asking what about the rate then? People, rate can differ according to concentrations also. And you know that it can differ according to concentrations also. So doesn't mean it should have the same. The rate of the reaction is directly proportional to the activation energy. No, when activation energy increases, rate decreases. That is also wrong. 15th on answer 5. 15th on answer 5. What about 16th on? The rate of a gaseous reaction A goes to B remains constant as long as the temperature remains constant. Rate of a gaseous reaction A gas goes to B gas remains constant as long as the temperature remains constant. No, we can change the concentration. Then second one, at a constant temperature, number of collisions between reactant molecules as well as fraction of molecules with sufficient energy for reaction remains constant. At constant temperature, the number of collisions between reactant molecules as well as the fraction of molecules with sufficient energy for the reaction remains constant. Constant temperature, the number of collisions between reactant molecules. If the reaction continues, it will decrease. At constant temperature, the number of collisions between the reactant molecules as well as the fraction of molecules with sufficient energy for reaction remains constant. ඒක නිකන් අර උඩින් බැලුවා මේක හරි වගේ තමයි හිතෙන්නේ because at constant temperature we are not increasing the concentration or anything. ඒක නිකන් හරි වගේ තමයි මට නම් හිතෙන්නේ. That statement looks correct. First statement, rate of a gaseous reaction remains constant as long as the temperature remains constant. That is wrong. Answer number 4 මම යනවා ඒකට. I'll tell you whether it changes or not. What about your ideas? Previous it says at a given temperature. What do you mean? Which question? Seventh one. We can't go back. I'll tell that later. Make a 5 people. A statement. The second statement is wrong. They are arguing like this people. The concentration reduces with time. As the reaction progresses, the concentration. As the reaction progresses, the concentration will decrease. Now let's say A goes to B, this reaction. Here people, as the reaction progresses at constant temperature, the number of collisions between react and the fraction of molecules is sufficient. It remain constant when why A will react. So the number of molecules of A in the mixture decrease. එතකොට ඒක constant වෙලා තියෙන්නේ නැහැ. හරි ඒක react වෙන හින්දා ඒක අඩු වෙනවා කියලා එකක් තමයි ගන්න වෙන්නේ. So that is answer number 5. What do you say, Farmer, firstly? Seventh one. Rate of a reaction consisting of several steps is determined by the step with the lowest activation energy. That is wrong. Seventh and second statement. Fifth one. At a given temperature, the rate of the reaction with lower activation energy will always be faster. මේක තමයි මං කිව්වේ මේ concentration can differ. හරිද? At a given temperature, කියන්නේ same temperature, the one with the lower activation energy will be fast. ඒක තමයි මම මුලින්ම හිතපු විදිය. That's wrong though. Why? Let's say low activation energy න අවුලක් නැහැ. හරිද? අරකට same. But the rate මේ මොකද rate equation එකේ තියෙන concentration can change නේ. If you change the concentration, then the rate will decrease. So it doesn't have to be equal like that, right? It doesn't have to be equal like that because the concentration can differ. So the rate depends on presence of catalyst. It depends on presence of what you call temperature, and it depends on the concentration. These three terms, it's going to differ. How is it? එතකොට අර special points එක ඔක්කොම මතක් කරගන්න. Sometimes when you change concentration, it doesn't change the rate. Sometimes if you always if you increase temperature or decrease temperature, the rate will change. If you add a catalyst, then activation energy does not reduce. It creates a new pathway with a new activation barrier. How does a catalyst change the rate? How does the catalyst change the rate? It changes rate by creating a new mechanism. හරිද? New mechanism. මේ mechanism එක හරහා අලුත් pathway එකක් දෙනවා. ඒ අලුත් pathway එක හින්දා sometimes the order of the reaction can be changed. These special points you need to have in your mind before going for the statement questions of kinetics. හරිද? අර order කතාව තාම අහලා නැහැ people. The order of the reaction can be changed. ඒකව අහලා නැහැ. ඒක change වෙන්න පුළුවන්. If they asked in 2025 A levels අර rate of the reaction මොකද මේ order of the reaction can be changed or could be changed can be changed කිව්වොත් එහෙම it can be changed by the presence of catalyst. Sometimes it can change because it gives a new mechanism. When it gives a new mechanism, the rate law can change. එතකොට must change කිව්වොත් ඒක වැරදි. The rate law again order of the reaction must change with the presence of catalyst. එහෙම නැහැ. Sometimes it doesn't change the rate law or anything. Sometimes it will change. හරිද? Keep that in your mind. 17th one. Which of the following statements is true? The rate of an exothermic reaction decreases with increase in temperature. No. Second one. Rate of endothermic reaction increases with increase in temperature. That is correct. Temperature has no effect on solid state reactions. That is wrong. A catalyst converts endothermic reaction to an no. Catalyst decreases the enthalpy. No. Very wrong. Second one is correct. Whatever exothermic or endothermic, when you increase temperature, the rate will increase. 18th one. Consider the following equilibrium at 100. Equilibrium, cut that. Cut the 18th one. It's KPKC. Le-Chatelier's principle. That is Le-Chatelier's principle. Cut that. 19th one. When a reversible reaction is at equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. When a reversible reaction is at equilibrium, the rate of the forward reaction make up equilibrium තමයි අවුලක් නෑ බලමුකෝ. When a reversible reaction is at equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. That is correct. Second statement, at equilibrium, the activation energy of the forward reaction is equal. නෑ එහෙම කියන්න බෑ. Even at equilibrium, people, the energy profile diagram will look something like this. Even though it is at equilibrium, the forward activation energy is this much, the reverse reaction activation energy is this much. So ඒක එහෙම තමයි. ඒක equal වෙන්නේ නැහැ. හරිද? It doesn't become equal. එතකොට first one correct, second one wrong, answer number 3. 19th one. 18th one එක නෑනේ. 19th one එක 3. 20th one. 20th one. Which one of the following statements is true regarding kinetics of a chemical reaction? First one, the unit of rate of a reaction depends on the overall order of the reaction. The unit of rate of a reaction, or rate of a reaction is mole per cubic decimeter per second. It doesn't change. That is wrong. Mathematical expression for rate of any reaction can be written using balanced overall chemical equation. No. No. They're asking about the rate law. By just writing balanced chemical equation, you can't get the rate law. That is wrong. You have to do an experiment to find the order of specific reactions. All කවුරු හරි කියන්න පුළුවන් people මේ elementary reaction වල එහෙනම් පුළුවන් නේ කියලා. Some might argue with you. Then you might tell we cannot determine the order of a reaction without doing an experiment. Then somebody else, a donkey, might say, then what about elementary reactions? We can write the order of the reaction by looking at the stoichiometry. Now, how about that? Then you have to say back to them, to determine whether it's elementary or not, we have to do an experiment. එච්චරයි. හරිද? කටවහන් යනවා ඊට පස්සේ. හරිද? Then third statement, rate of all reactions increase with temperature. That is correct. Fourth one, overall rate of a multi-step reaction depends on rates of all steps. No, that is the slowest step. Depends on the slowest step. That is wrong. Fifth statement, the activation energy of a reaction changes when the initial concentration of reactants are changed. Activation energy of a reaction changes when the initial activation energy and concentration does not have any effect at all. 20th on answer number 3 then. Temperature increasing will always increase the rate of the reaction. 21st on, which of the following statements regarding a catalyst is valid? It changes the enthalpy. How many times did you see this? Now this is like very vomitish, right? Catalyst changes enthalpy, catalyst changes enthalpy, catalyst changes enthalpy. Every year they are asking that, right? බලන්න කලිනුත් තිබ්බනේ ඔය. In question number 17, 2006. Right? 2006 they gave it in the fifth statement. Catalyst decreases enthalpy. Then somewhere else also you found that. What the? See? Nah, enthalpy of the reaction decrease. I found it like 3 or 4 times. 2002. 2002 third statement. Catalyst reduce the enthalpy. How is it? You can see. Same thing they're asking again and again. It changes enthalpy. That is wrong. Second statement. It decreases the activation energy. According to new syllabus, wrong. According to new syllabus, wrong. Decreases activation energy, wrong. It is not consumed during the reaction. That is correct. First statement wrong, second statement wrong, third statement correct. It increases both rates of forward and reverse reaction of a chemical reaction at equilibrium by the same factor. That is coming under equilibrium, but that statement is correct. C and D correct. Answer number 3. In the marking scheme, if you find answer number 5, it is because in all syllabus, second statement they took it as correct. So all syllabus එකේ එහෙම scene එකක් තියෙනවා. The decreases activation energy කියන එක new syllabus එකේ වැරදි. So pay attention to that. 22nd one. In a chemical reaction, all molecules with energy greater than activation energy form products. Tell me about that. Correct or not? According to your knowledge on collision theory, tell me whether that's correct or not. Tell me quickly. Collision theory. Is that correct or not? No, doesn't have to be all products. Yes, they require proper collision. They require proper orientation. They should collide. They should have proper orientation in order to form products. Doesn't mean everyone can form products. So that is wrong. That is wrong. Second statement, in all chemical reactions, the reactants must go through a state having energy greater than the energy of reactants. In all chemical reactions, reactants must undergo. Yeah, that is correct. All chemical reactions undergo this process, people. All chemical reactions has an activation energy of its own. After passing through this transition state, only they go to the products. Even after coming to this place, doesn't mean it will proceed this way. It's like a balance point. Take a coconut shell, take a coconut shell and put a marble on top and then leave it there. It could go to either direction, right? Depending on small slight changes, it could change direction and go here and there. So same like that doesn't mean like if it comes to transition state, it will go to products. It could also go to reactants. However, the thing is, it should definitely go through a transition state, which is having energy greater than the initial energy. So 22nd one, first statement wrong, second statement correct. Answer number 4. 23rd one. Consider the following statements regarding kinetics of a chemical reaction. A. Unit of rate is mole per cubic decimeter. No, mole per cubic decimeter per second. एक typing mistake ද දන්නේ නැහැ. I don't know whether it's typing mistake or not. Mole per cubic decimeter per second එකක් එනවද නැද්ද දන්නේ. But mole per cubic decimeter is not the rate definitely. හරිද? According to this tube time telling. B. Increase in temperature decreases the rate of an exothermic reaction. මේකම කී පාරක් ඇහුණාද people? This B statement, how many times did you hear? අර කලිනුත් තිබ්බ නේද? That statement is wrong. I told you it always increases the rate of a reaction. Temperature increase, rate increases. A wrong, B wrong. Increase in concentration of reactants does not have an effect on overall order of a reaction. Increase in concentration of reactant does not affect the overall order of a reaction. That is correct. Metana people, I think there's a printing error. Which of the following statements regarding chemical kinetics of a reaction are true? A is wrong according to this one. B is definitely wrong. C should be correct. Then answer number 3. Ne? Hembelu answer number 3. I know. Increasing concentration does not have an effect on total order of reaction. Yes. Answer number 3. 23rd one, answer number 3. 24th one. As long as temperature is maintained constant, the equilibrium constant of a chemical equilibrium does not change by the addition of a catalyst. As long as the temperature is maintained constant, the equilibrium constant of a chemical equilibrium. Shall I skip that? Okay, let's do with you. As long as the temperature is maintained constant, the equilibrium constant of a reaction, equilibrium system does not change by addition of catalyst. That is correct. The equilibrium constant of an equilibrium reaction does not change by adding a catalyst. Catalyst decreases activation energy of both forward and reaction by the same fraction. That is correct. Answer number 1. I won't go much detail into it because this is equilibrium. This is equilibrium concept. 25th one, the order of the reaction N2O5 goes to NO2 plus O2 can be determined by monitoring the volume change of the system within a given time when a sample of N2O5 gas is heated. That is correct. No, that is wrong. The order of the reaction can be determined by monitoring the volume change of the system with time. ඒක ගන්න අමාරුයි නේද people? එහෙම ගන්න අමාරුයි. කියන්නේ O2 gas තියෙනවා, NO2 තියෙනවා, N2O5 තියෙනවා. It's like very hard to obtain like that. I'll take that statement as wrong. Second statement, the order of a chemical reaction with respect to reactant does not depend on the concentration of the reactant. Order of a chemical reaction with respect to a reactant does not depend on the order does not change according to concentration. That is answer number 4 then. Wait, I'll check on this further. Volume we take definitely. I don't understand. Mogadda, Pharma firstly, I didn't understand what you told. Yes, 47 first statement wrong. I'm correct. That thing is correct. Hurry. 25th on answer number 4. Because the thing is, people, the first reaction, again, in the left hand side, that reaction, it's like just imagine N2O5 is also gas, NO2 is also gas, O2 is also gas. How are you going to measure the volume and take the amount of oxygen produced? It's very hard and you can't do that. Impossible. Twenty-sixth one. 26th one. Gases A and B react to form product B. Material X in a fine particle of form has been suggested for the use of catalyst for this reaction. Material X provides an alternative mechanism consisting of 3 steps. The activation energy for 3 steps of the reaction without X is given below, and with X is also given. Without X, it's a single step reaction. Alternative mechanism, yeah. එහෙම single step කියලා නෑ. හරි, with X මෙච්චරයි. Use of X will not change the rate significantly. Step 1, step 2, step 3. It will neither. X is step 3 is 50 kilojoules per mole. Yeah, it will not change significantly. You can see step number 3, that is still 50. Nothing changes now. Without X is also 50. With X it is 50 and it adds 2 more steps also. So doesn't make any sense. A is wrong. B, Activation energy of the step 3 can be lowered by using more X. No, 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 you can't do that. Use of X increases the rate of the reaction because X is the material with larger surface area. No, that doesn't happen like that. Gases A and B, again, X එහෙම මුකුත් කරන්න X will give a mechanism, right? That is wrong. Increase in temperature will increase the regardless of whether, yeah, increase in temperature will increase rate. So this one I'll go with answer number 5. 26th one, 5. Yes. Kinetics we take volume same. Ayyo. How, why? How did you know? Like, hey, මොකක්ද? What is that? Are you referring to proper experiments? හරිද? මොකක්ද මං කිව්වේ? Volume is constant only in the solution. Solutions දෙකක් mix කරලා final volume එක equal කරනවා. පාඩම් කරනවා කියලා ඔහේ පාඩම් කරන්න එපා මොකෙද්ද වගේ. හරිද? ඔක්කොම ටික දැන් මේකත් ඒ volume equal වෙන්නේ නැහනේ. In this one, volume doesn't become equal, right? This is just a reaction. This is like the magnesium HCl reaction. Check magnesium HCl reaction. You're gaining the hydrogen volume. Volume equal කරන්නේ නැහනේ. Solutions වලනේ volume equal කරන්නේ. තේරෙනවද? Right? එතකොට මේ change in volume divided by the time taken will be the rate. හරිද? Change in volume divided by the time taken will be the rate. ඒකෙන් different volumes ගන්න පුළුවන් ඕන. If you want, you can take different volumes. හරි? 26. Yes, ඒක හරිනේ. ඒක හරි. Sorry. Answer 4. Sorry. Answer 4. 26 4. ඒක පළවෙනි statement එක වැරදි කියලා ගත්තේ නැහැ ඒක. හරි. Then 27th one. 27th one. Increasing the temperature will always increase the reaction rate. Yes. ඒක දැන් කීපාරක් ඇහුවද? Previous question also you had. Activation energy of a reaction decreases when temperature. No, that is wrong. Answer is answer number 3. 27 answer 3. 28. At constant temperature, doubling the concentration of all reactants in elementary reaction increases the rate by a factor of 8. At constant temperature, the doubling the concentration of all reactants at constant temperature, doubling the concentration of all reactants in an elementary reaction increases the rate by a factor of 8. Balo. Initial rate is R is proportional to concentration of A squared concentration of B ne. R2 is proportional to concentration of A twice, 2 times ne, squared times concentration of B 2 times. So that is 2 into 2, 4. 4 into 2, 8. Yeah, that is twice. Ne? It will become twice. By a factor of 8, that is correct. In an elementary reaction, the order with respect to reactant is equal to its stoichiometric coefficient. So that is answer number. Explain කරනවද නැද්ද කියන එක තමයි ප්‍රශ්නේ නේද? We have to take it as answer number 1. It explains. අර ළඟින් හරි යනවා නම් answer 1 කියලා ගන්න people don't hesitate. but අන්න මේ පළවෙනි එකේ තියෙන වචන ටිකම මේකේ තියෙනවා දෙකම හරි වගේ හිතනවා නම් එක දාලා දාන්න. Like there's a 90% chance that it is correct. මේක probability වලින් ගන්න එක නෙමෙයි. The thing is අර එකද දෙකද කියලා select කරන එක සමහර වෙලාවට පට්ට අමාරුයි exam එකේදී. Under so much stress conditions and where the professors are thinking for different kind of questions, it's very hard. It's very hard to select whether it's 1 or 2. එතකොට මේ දැන් මෙතන නම් elementary reaction, the order with respect to reactant is equal to its stoichiometric coefficient. මෙතන අර පළවෙනි එක ගන්න පුළුවන් වෙන්නේ ඒක හරි හින්දානේ. නෑ ඒ වගේ හිතලා answer number 1 කියලා ගන්න පුළුවන්. Because we took the order by looking by the statement by elementary reaction. Hari. ඒක 1 කියලා ගන්න මෙහෙමයි ඉතින්. දැන් how did you take in the first statement? ඒ කියන්නේ rate එක proportional to the ඒ කියන්නේ order එක හෙව්වේ කොහොමද? How did you find the order? You took the order by looking at the stoichiometry නේ. How did you do that? Because it's an elementary reaction. ළඟින් ගියත් එක කියලා ගන්න පුළුවන්. අර ඒ පොඩ්ඩක් ළඟින් ගියත් එක කියලා ගන්න පුළුවන් ඉතින්. Like ඒක එහෙම තමයි. There's a 90% chance that you are correct. Sometimes they will give answers for 1 and 2 both. හරි right. එතකොට 28 1 29 consider the following elementary reaction. Rate constant of the reaction at temperature T is K. ආයක calculation එක ගන්න බලමු. Rate constant of a reaction at temperature T is K. N moles of A and N moles of B were mixed and allowed to react in a rigid container of volume V. If the universal gas constant is R and the rate of the reaction at T equals CRT. N moles were mixed and allowed to react in a rigid container. If the universal gas constant is R, the rate of the reaction at time T is Q. Rate of the reaction at time T is Q. Initial situation. R equals K times concentration of A. This is an elementary reaction, so we can write like this. At temperature T, it is K. N moles of A and N moles of B were mixed together. R equals K times N over V. That is the concentration of A. Then concentration of B is also N over V. If the universal gas constant is R and the rate of the reaction at time T is Q. After time T, what happens is they will react. After time T, what happens will they will react. A plus B goes to C. N moles, 0. Let's say X amount reacted, then this is plus X. This is N minus X. This is also N minus X. So total number of moles at the end will be, make kapena, so 2N minus X will be the total amount of moles. Hari? Will be the total amount of moles. They're asking the rate of the reaction time is Q, the pressure P of the vessel at time T. Pressure P of the vessel at time T. Now, after time T, we can write R equals K times concentration of A now in the mixture is N minus X over V. And then this one, N minus X over V. Now the rate has changed. They have given any value for it? No. Rate constant of a reaction they have given. Rate of the reaction at time T is Q. මෙහෙම දීලා තියෙනවා. Initially rate එකක් දීලා තියෙනවද නැහැ? Initially rate එක දීලා නැත. හරි. Rate of the reaction at time T is Q. Of the vessel at time T is given by. හරි. එතකොට pressure P of the vessel is given. PV equals nRT. If we apply, we can subject X out of it and we can substitute into X. PV equals total number of moles at the end, 2N minus X. Pressure we know, volume we know, number of moles is the total amount, nRT. Constant temperature. Constant temperature. එතකොට we can write 2N minus X equals PV over RT. And then X equals 2N minus PV over RT. 2N minus PV over RT. Oh my God, I had to substitute into this now. So I can write this one as squared, ne? I can write this as squared. Instead of minus x, I am putting this 2n minus pv over rt. මට මෙහෙම ලියන්න පුළුවන් q equals k times n over v minus x over v. n over v minus x over v කියලා ලියන්න පුළුවන්. So I can substitute this one there. එතකොට මේක substitute කරාම n over v minus, instead of x we are putting this one, so it becomes 2n over v minus 2n over v plus pv over rt, so p over rt, p over rt, then q equals k times n over v minus 2n over v p over rt. Q equals k times p over rt minus n over v. Right? Minus n over v. So we have to subject p out of this. P over rt is equal to q over k plus n over v. P equals q over k plus n over v multiplied by rt. Q over k plus n over v minus answer 4. Here you go. That's it. Answer number 4. Then can I erase the board? මම ඔයගොල්ලන්ගේ රුපියල් 3200ට උපරිම සාධාරණයක් කරනවා, like maximum benefit for your to 3200. There are 3 classes per week. හරිද? Average time of a class is 2.5 hours. Normally 4 classes, and that's all the revision class will give me. Normally 4 classes. I'm doing how much? 12 classes. 3 times. හරිද? Very nice. Maximum benefit for you. 4 classes. Now 2-3 classes per week, and sometimes extra classes might be there. This week, industrial classes, like sometimes it was like very less time because you haven't got your tubes, and I had to do magnesium production freely. Magnesium production free session එකක් විදියට කරන්න ඕන වෙලා තිබ්බා මේ අර that hacks and everything වදයානේ ඒකත් එක්ක ඒක free කරන්න ඕන වෙලා තිබ්බා. අනිත් ඒවා I wanted to do it with you guys. It's a slow process, I think. Like sometimes I regret certain things while doing classes. Sometimes students come and then students go. It's like up and down movement. It's like your marks. My student count in the class is like up and down. And I don't know, 2025, when 2025 is over, I don't think I will have even 10 students in 2026. Like freshly starting, you guys know me mainly because of Rankers Club and stuff. 2026 people might not know if I don't do the work in the Rankers Club like last year. I will have students back then. Otherwise, it's going to be hard. It's going to be really hard to collect students from 2026, 2027 batches. Because it's hard, you know, right? It's a very hard thing to do class. It's not the easiest thing to earn money. It's so much stress, and it's a big responsibility. When you see a student writing paper in a Zoom meeting or in a class, you feel like if I'm the teacher, I feel so අර පව් කියලා හිතෙනවා නිකන් බලද්දි. Like they travel so badly, they study and then write the papers and then you feel like you have to give the full thing for them sometimes. හරි. No. Sometimes I regret eating. It's like a lot of work. I could have stayed freely at home without doing anything. I wouldn't have money also. Can mugut na. I wouldn't have buy an iPhone 16. No laptop Asus. Nothing. Me mukut na. Mukut ma na. Just I would stay at home doing nothing. So I print my own tutes right now. එතකොට that's a development. Up and down moment. Yeah, the laptop which I was using before I buy this. Before I buy this, the laptop which I was using, it's broken now. If I didn't buy this, it would have been broken. It's a i7, but its gen is very low, like very old. In 2016 or 17, we bought it, so it's very old, and it's now broken. And if I didn't buy this, then I might not be doing classes right now. I would have just given 1 or 2 weeks break. No. I don't regret. It's life is always ups and downs, people. You can't make it very easy. It's not very easy. You see now there are single medium teachers like very at the top. They're at very top. They're so famous. Like I used to go to their classes and they were like so. I mean, they are very at top level. Physics, maths, whatever the subject. They didn't just go there. හරිද? නිකම් මෙහෙම නෙමෙයි ගියේ. If you know their life story behind what happened, you might know it. හරිද? එතකොට there are ups and downs in everything you do, there are ups and downs. එතකොට ඔය කට්ටියගේ marks ටිකත් ඒ වගේ තමයි. Now let's say you are increasing your marks, it's like going up and down, up and down, up and down. එතකොට මම ඔය කට්ටිය final papers එම ලියන ඇතිනේ. හරි සමහරව කට්ටිය. මම final paper 1 එකෙන් තමයි ඇතුළට ගියේ. I went into the paper class with final paper 1 and I had only 62 marks. මේක කෙමිස්ට්‍රි වල මම කියන්නේ හරිද මේක මම ඉන්ක්‍රීස් කරා last paper before the exam ETP 7 එක ETP 7 එක වෙන්නේ නෑ 6 එක 6 එක හරි 7 එක හරි I got 78 හරිද I got 70 the paper was hard still 78 එතකොට මේ day before the exam I just sat right here in this room මෙතන ඉඳගත්තා මෙතන හරිද මෙතන I wrote an MCQ paper 50 MCQs වදියානේ 48 correct හරිද මේක තමයි before the exam before going to the exam completely new 50 questions and this is what I got. එතකොට මේකේ වැරදුනේ industrial දෙකක්. ඒකේ වැරදුනේ industrial දෙකක්. හරිද? මේ ඒක මං අර industrial මම essay ලියන්න බලාගෙන නෙවෙයි හිටියේ. ඉතින් වැඩිය බලාගත්තේ නැහැ ඒ කාලේ. හරිද? Now of course can. එතකොට ඒ කාලේ එහෙමයි. හරි මේක මට A level paper එකේදී I got this one. හරිද? එතකොට මේක ගන්න how much I worked at the beginning here I had 30 හරිද මෙච්චරයි තිබ්බේ. This was like 3 months before the exam. This is 3 months before the exam. Trust me or not, this is 3 months before the exam. First shy I did 32 out of 50 in the A level paper. හරිද? First shy, this is first shy. එතකොට මේක after 3 months before the exam 62 that is 30ක් ඇවිල්ලා තියෙන්නේ MCQ එකෙන් MCQ 30යි හරි. හරිද? එතකොට මෙතන ඉඳන් මෙතෙන්ට යන්න අතෙන්ට යන්න you have to review question reviewing MCQ review and correcting your mistakes and then chase behind A plus points chase behind good points again good points අලුතෙන් දෙයක් හම්බුනොත් write it in a separate MCQ point book or something or target කරන්න ඕනේ definitely the statement type questions because I've had so many papers where I got all first 30 questions correct හරි like back to back 1 to 30 correct 1 to 30 correct 1 to 30 correct 1 to 30 correct ඊට පස්සේ 31 to 50 messed up at least 5 or 6 wrong every time I write a paper that happens Hari? So you have to target those type of questions the statement type questions you have to target so the new points you will find do new papers ඔක්කොම papers අහුවෙන හැම එකක්ම just look at 31 to 50 before going to the exam. හරිද? We'll do it in the rankers club last hope මේ chemistry thing. එතකොට ඒකෙත් කරමු questions, statement type questions and stuff. එතකොට yeah, we'll do so many questions of statement type questions so you can reach this target. It's not a hard thing. Thank you. Thank you. Okay. So 30th one. 30th one. The energy diagram for the reaction X plus Y goes to Z is shown. The rate of this reaction is dependent on. Rate doesn't depend on enthalpy. You know that. Rate doesn't. Again, E3 කියන එක wrong. Fifth one wrong. Fifth one wrong. Third one wrong. Then first one E1. E1 is the rate activation energy of the forward reaction. That is correct. E1 only the E2. The E2 is the backward reaction. The enthalpy of the backward reaction. මේ මොකද activation energy of the backward reaction. ඒක වැඩක් නැහැනේ. එතකොට energy diagram for the reaction X plus Y. The rate of this reaction. එතකොට E1 only. Answer number 1. Pharma first. It's not for you. I didn't tell thank you for you. Answer number කීයද මං කිව්වේ? 1. 31. The gas A dissociates at temperature T according to the elementary reaction. A gas goes to 2B gas and then C gas. Sample of A gas was placed in a closed container and allowed to dissociate at temperature T. The initial pressure is P naught and pressure at time T is P. We have to draw. A gas goes to 2B gas plus C gas. Sample of A gas was placed, allowed to dissociate. The initial pressure is P naught. A gas was kept, again, P naught. At time T, it is P. So let's say P dash will react, then this becomes plus 2P dash, this one becomes plus P dash. Then P naught minus P dash, this is 2P dash, this is P dash. So altogether P naught, total pressure they say it is P, right? P equals P naught plus 2P naught, 2P dash. P naught plus 2P dash. Identify and the pressure at time T is P. එතකොට මේකේ අපි P dash subject කරොත් P minus P naught divided by 2. So they're asking, identify which of the following terms is proportional to the rate at time T. Rate is proportional to P naught minus P dash. So P dash equal P minus P naught over 2. R is proportional to P naught minus P minus P naught over 2. එතකොට R is proportional to P naught minus P over 2 plus P naught over 2. එතකොට P plus P naught over 2 is 3P naught over 2. 3P naught minus P over 2. 3P naught minus P over 2. 3P naught minus P over 2. Hi. එතකොට proportional නේ. 2 is a constant නේ. 2 is a constant. They're asking R is proportional. You can eliminate the 2. Then 3P naught minus P. 3P naught minus P. That is answer number 3. මේක අහන්නේ proportional people. Proportional කියවම numerator එක minus P, denominator එක 2. ඒතර denominator is a constant. ඒක අයින් කරන්න ඕලා. But P naught and P is not a constant. It can change. They can change. Answer 3. Give me 1 second. Hari, එතකොට 32. I'm erasing the board. Can I erase the board? Are you writing still? Done. Okay. Your silence, I am taking it as a yes. 2 people said done. Others no talking, nothing. Second one. This one easy, right? Rate of the reaction with respect to permanganate. Change in concentration of MnO4 minus divided by delta T multiplied by 2 is going to be equal to oxalate එකේ delta C2O4 2 minus divided by delta T multiplied by 5. This one you learn. We did this question also. So it's going to be 2 over 5. 2 over 5 change in concentration. Answer 4. 34, 32 answer 4. 33. 33 look statement type questions. Which of the following statements is or are false with regard to order of a reaction? Order of an elementary reaction should be a whole number. No. Elementary reaction, yes. Elementary reaction, yes. Aye. Elementary reactions කියන්නේ මොකක්ද? Single step reactions. Single step reactions කියන්නේ මොකක්ද? One per molecule. Again, molecules are reacting together. ඒ කියන්නේ මෙහෙමයි. For example, හිතන්නකෝ A2 molecule reacts with B to form A2B. මෙතෙන්දි වෙන්නේ A2 molecule is like this. හරිද? B molecule is like this. They are going to react together to form A to B. They are going to form A to B. එතකොට you can see here order එකක් ලියද්දි මේකේ order එක කියන්නේ මොකද්ද? මේකේ stoichiometry එකනේ. මේකේ order එක කියන්නේ මේකේ stoichiometry එකනේ, elementary reactions. This one doesn't become half ne. Normally, like when a reaction is happening, do you see only half of this is reacting with that? එහෙම වෙන්නේ නැහැ නේ people. Water molecule එකේ භාගයක් react කරනවා. එහෙම වෙන්නේ නැහැ නේ. P එකක් කරන් කපන්න බෑනේ people. Water molecule එක. You might say water drop I can cut it into two, but you can't cut a water molecule in half. හරිද? oxygen එක මැදින් කපනවා. එහෙම කපන්න බෑනේ. You can't do that. එතකොට elementary reactions වල order එක it should be always a whole number. Do not forget that. හරිද? elementary reactions වල 1 වෙන්න පුළුවන්. 1 2 3 4 අන්න ඒ වගේ අර දන්නවනේ elementary reactions it should be whole number. Others, all other reactions order can be decimals, order can be fractions, whatever it is. අනිත් ඒ වගේ අර වෙන multi step reactions වල ඒ වගේ වෙනස් වෙන්න පුළුවන්. Order of a reaction is experimentally determined value. That is correct. So ඒක අර පටලන්න දීලා තියෙන්නේ. මං කිව්වනේ order of a reaction is experimentally determined. Then if some donkey says what if it's an elementary reaction, we can look by the stoichiometry and tell. Then you have to tell that donkey back. What you are going to tell? The reaction, whether it's elementary or not, we have to do an experiment and only see that. හරිද? ඌට නිකන් කියන්න බෑනේ එහෙම මේක elementary කියලා. We have to do an experiment and check whether it's elementary or not. ඉතින් elementary නැද්ද කියලා බලන්න. ඉතින් order එක බලන්න ඒක ඕනේ ඉතින්. So definitely you have to do an experiment. You have to do an experiment. එතකොට B එක correct. B එක correct. A එක correct. Order of a reaction is always equal to the sum of the stoichiometries of coefficient in a balanced chemical equation. එතකොට මෙතන කියලා නැහැ මොකක්ද elementary කියලා. Order of a reaction is equal to the always equal to the sum of stoichiometric coefficient. එහෙම වෙන්නේ නැහැ. හරිද? Only in elementary reactions that is correct, but this is wrong. This is not for all reactions. So multi-step reactions වල එක වැරදි. C is wrong. D, order of a reaction is the sum of powers of molar concentrations of the reactants in the rate law expression. Order of a reaction is the sum of the powers. Order of a reaction sum of powers of molar concentration of rate law expression. නෑ එහෙම වෙන්නෙත් නෑ. ඒක correct only for elementary reactions. D එක correct වෙන්නෙත් only for elementary reactions, not for other reactions. So A and B correct, answer number 1. 33 answer number 1. 33 answer number 1. 34. Which one of the following statements is false with regard to activation energy of a reaction? A, activation energy of the forward reaction is an exothermic process. In an exothermic process is lower than the backward reaction. The activation, which of the following is correct regarding activation energy? Okay. Activation energy of the forward reaction in an exothermic. Exothermic කියන්නේ මොකද්ද? මෙහෙම ගියා මෙහෙම ආවා. හරිද? Forward reaction process is lower. ඒක හරි. Activation energy of the forward process is lower than the reverse process. ඒක හරි අවුලක් නැහැ. Shape. A is correct. B, activation energy of a slow reaction is less than a fast reaction. No, in a slow reaction, normally the activation energy is larger. Eka wrong. C, activation energy of a given reaction pathway is unaffected by a catalyst. Activation energy of a given reaction pathway is unaffected by catalyst. Eka hari according to new syllabus. හරිද මම මේ කියන්නේ new syllabus එකේ C එක හරි all syllabus එකේ C එක වැරදි. හරිද? අර given path එක කියන්නේ reaction pathway is unaffected. given reaction pathway නේ. ඒ original pathway එක unaffected. ඒක තියෙනවා. catalyst එක අයින් කරපු ගමන් starts to go in the old way. ඒක තමයි එතන කියන්නේ. එතකොට A එක මොකද්ද? A එක හරි B එක වැරදි C එකත් Hari, D එක higher the initial concentration of reactants, lower no, it doesn't affect. Anyways, answer number 5. Even if C is wrong, it is 5. Even if C is correct, answer 5. So here I'll write A and C correct. A, C correct. A, C correct, answer 5. They're asking which are false. Hari අවුලක් නෑ 8 5 නේ. Then you're lucky people. In the exam, if you think like they're asking the true statement and you get something like this, you're lucky. Very lucky. Yes. Which question? 33. Did I do a mistake? First statement, okay. ඒක අවුලක් නැහැනේ. B statement, the order of the reaction is experimental hari. C statement, order of reaction is always equal to the sum of stoichiometric coefficient. No, that is wrong. The order of a reaction is the sum of the powers of the molar concentrations. Order of the reaction is the sum of එක හරි නේද? අර නිකන් total order එක ඇහුවම orders ටික එකතු කරලා ලියන්නේ. It doesn't matter if it's elementary or not නේ. හරි. ඒක ඔයා හරි. That is correct. එතකොට answer 5 වෙන්නේ මේකට. 33 එක 5 කියලා දාගන්න. Part D. ඒ කියන්නේ D statement is correct. ඒ කියන්නේ අර අපි අර questions වල කරන්නේ people find the order with respect to A, find the order with respect to B, and then find the total order. Then what you do, you're going to add them up නේ. 1 and 2 you're going to add together. අන්න ඒ වගේ එකක් අහන්නේ. ඒක correct. Oh, hari. Yeah, that's correct. Good. 35th one. Most reactions take place more rapidly at higher temperatures than lower temperatures. Which of the following statements give the correct explanation to this observation? The increase in temperature increases the activation energy of the reaction. Wrong. The increase in temperature decreases activation. Wrong. When the temperature increases, the number of collisions per unit time increases. Per unit time, per unit volume increases. That is correct. The increase in temperature results in increasing percentage of high energy collision. That is also correct. C and D correct. Answer number 3. Answer 3. 35, 3. 36. 36. Which of the following statements is always true regarding rate of an elementary reaction? Rate can be increased by increasing concentration. That is increasing temperature. That is correct. Rate can be increased by removing products. No, that is for element equilibrium reactions. That is wrong. Rate of the reaction depends on the rate of the slower step. Elementary reactions do not have slower step, faster steps. That is wrong. They're asking which of the following is true about an elementary reaction. So it doesn't have a slow step, faster. It's just a single step. Rate of the reaction can be increased by making delta G. No, that is wrong. B wrong, C wrong, D wrong. Answer 5. 36, 5. 37. Which of the following statements is true for a balanced chemical equation of an elementary reaction? The order of the reaction is same as a molecularity. එක හරි. Molecularity එකයි order එකයි same in a elementary reaction. I told this in the note. Order of the reaction is less than the molecular. Wrong. The order of the reaction is higher than molecular. Wrong. Molecularity cannot be 0. That is correct. Molecularity cannot be 0, people, because the molecules are going to collide with each other. Molecules are going to collide with each other. Elementary reaction එක molecularity බිඳුවක් වෙනවා කියන්නේ there are no reactants. There are no molecules reacting. It doesn't make any sense. That one also A correct, B wrong, C wrong, D wrong. D correct. Molecular cannot be 0. D correct. So answer is answer number 4. 38th one. 38th one. 38th one. The initial rate of a zero order reaction is R naught. R naught equals K. Zero order. The rate of the reaction by initial concentration doesn't depend. Ayyo, it is K tamai. The rate of the reaction when the initial concentration is reduced by 50%. Rate of the reaction same thing K. Zero order. Zero order means it doesn't depend on the concentration. If it doesn't depend on the concentration, whatever the thing which you put there doesn't mean, right? Doesn't matter. Whatever the concentration, 150%, 1000%, whatever, it doesn't matter. It's same. It's K. 39th one. Which of the following is always correct for the slower step of a multi-step reaction? Its molecularity is an integer. People, multi-step reactions, I told you, each step is a single step reaction, no elementary reaction. So part A, its molecularity is an integer. That is correct. In elementary reactions, molecularity is an integer. That is correct. Its molecularity is higher than the overall order of the reaction. No, molecularity is equal to order of the reaction in a elementary step. That is wrong. A correct, B wrong. Overall rate of the reaction depends on its rate. Huh? Overall rate of the reaction depends on its rate. Slowest step. Yes, that's correct. Overall rate of the reaction depends on the rate of the slowest step. That is correct. So A correct, C correct. It's definitely answer number 5. Its molecularity is equal to the number of steps in the reaction. No, that is wrong. Hurry. Molecularity is equal to the number of steps in the reaction. First statement correct, second statement wrong. C statement correct. Molecularity is equal to the number of steps in the reaction. That is wrong. A and C correct. Answer 5. 39 answer 5. Make A කියලා දාලා තියෙන්නේ මොකද? Answer 1. Hurry. 40th one. This is 2017 question number 38. I will never forget this question. Which of the following statements is correct regarding an elementary bimolecular reaction in the gas phase? You know why don't I forget this? The teacher I went in the class, he gave this exact question. That's why I told you I got 46 MCQs correct. I remember this question. He got this question in the A-level paper. He wrote exams in 2017. That teacher got this one in his exam and he got 48 MCQs correct. And then this was one of the questions which he got wrong. I will never forget this question. He told, okay, let's review. First statement. The experimentally determined order of the reaction is only 2 when the concentration of reactants are equal. Look, elementary bimolecular reaction, so they are elementary. Experimentally determined order of the reaction is 2 only when the concentration of reactants are equal. No, that doesn't have to be equal. Eka varadi. Experimentally determined order of the reaction becomes 3 when the concentration of reactants, no, order doesn't change its concentration. C, when the concentration of one reactant is large in excess compared to the other, the rate of the reaction becomes independent of the concentration of that reaction. That is wrong. Although it is like if we increase the concentration of that particular reactant, doesn't mean that the reaction becomes independent of that. If we reduce the concentration again, it is become dependent. Independent when that is the statement. So that means that statement is wrong. C statement is wrong. When the volume of the container containing reactants is reduced at constant temperature, the rate of collision between reactant molecules increases. That is correct. Correct. 2017, 38 answer number 5. 38, 40. 40 answer number 5. एक highlight करना question 40 part C 2017 38 question part C, highlight that statement, very important. මේක island 4th වැරදිච්ච MCQ එකක්. හරිද? You might know who am I talking about. ඒක MCQ එක මම දවස්වල I was like what the heck, how did he get it wrong? Make question එක, this is very important question. හරි? Concentration of one of the reactants is large in excess compared to the other, the rate of the reaction becomes independent. Independent when? Don't forget that. 41st one. 41st. Elementary reaction to A gas goes to B gas occurs in a closed rigid container at constant temperature. Initial pressure of the container is P naught and the pressure when the rate of the reaction is half. Now people, can you remember question number 38? In question number 38, they gave that the order is 0. They gave the order is 0 and they asked like concentration is reduced and increase a 50% value. They are the rate, order of the reaction was 0. Here they are giving an elementary reaction. So here you should be able to calculate the order. R equals K times concentration of A squared. Why? Because it's an elementary reaction and the stoichiometry is 2. Initial pressure of the container is P naught, okay, and the pressure when the rate of the reaction is 50% of the initial value. Rate of the reaction is 50%. It can be 0.5 R. Initial value is PF, pressure, and the pressure when the reaction rate, and that means the total pressure they are talking about. Concentration of A definitely has reduced. So I'll put there A naught. Now, මෙතන A naught දාන්නකො. Initial is A naught. And then finally A squared. I need to find A squared now. Hurry, I need to find that value. So let's see. So A gas goes to B gas. 2A gas goes to B gas. Initial pressure is P naught. Then changed amount is P I'll tell. Minus P. This one becomes minus 0.5 P. නැත්තම් half P. Minus plus half P. Then P naught minus P. This is half P. P naught minus P plus half P becomes equal to PF. එතකොට P naught minus half P. P naught minus half P equals PF. Then I can subject P out of this. P is equal to P naught minus 2 times P naught minus PF. 2 times P naught minus PF. Hurry. 2 times P naught minus PF. Now I can write this is proportional to, now this one is proportional to the pressure. Why is that? P equals CRT. At constant temperature, pressure is proportional to the concentration. So instead of the concentration, I can put pressure. Initial pressure is P naught. So I can write R is equal to K times P naught squared. Initial pressure P naught. Then finally it is P naught minus 2. P naught minus P. P naught minus P squared. How is the P naught minus P squared? And you know a value for P. I'll keep that aside. How is it? I'll just keep that aside like this. P equals 2 times P naught minus PF. I'm going to divide these two together. So it is 1 divided by 0.5 is 2. 2 equals K and K cancel off. P naught squared divided by P naught minus P squared. They're asking value for PF minus P naught. So let's see. I'll take P naught minus P to other side. So if I square root both, I'll get root 2. Root 2 multiplied by P naught minus P is equal to P naught squared. So instead of P, I'm putting this. Root 2 multiplied by P naught minus 2P naught plus 2PF. plus 2PF. නේ මේක P වෙනකොට මේක දැම්මහම minus 2P naught minus into minus plus 2PF. This one cancel off. මේක P naught squared දෙන්නේ නැහැ. මේක square root කරනවානේ. එතකොට P naught. එතකොට root 2 minus P naught. root 2 minus P naught plus 2PF. root 2 minus P naught plus 2PF is equal to P naught. This P naught goes to other side, 2P naught. So they're asking PF minus P naught, right? PF minus P naught, PF minus P naught, PF divided by P naught. I'm not getting an answer. Let's see. I got initial rate of the reaction R equals K times P naught squared. Hurry. P naught squared. Then the rise chart. A goes to B. 2A goes to B. To the P naught. Minus P plus 0.5 P. P naught minus P. 0.5 half kilogram half P plus half P. This one becomes plus half P. P naught minus P plus half P becomes equal to PF. So the P naught minus half P becomes PF. P is equal to P naught minus PF. P naught minus PF multiplied by 2. Now you can write R is proportional to P naught minus P. P naught minus P squared. Right? P naught minus P squared. So this is 1, this is 2. 0.5 R. 50%. 50% of the initial amount. Can 50% of initial amount is 0.5 R. Right? 0.5 R. Then make a PF නෙමෙයි PT කියලා තියෙන්නේ මොකක් හරි කමන්නේ whatever. So 1 divided by 2 is 1 over 0.5 is equal to P naught squared over P naught minus P squared. හරි. එතකොට I can write it like this. P naught minus P squared over P naught squared will be equal to 1 over 2. කොහොමද කරේ කියලා දන්නවනේ. I just cross multiplied. I'll take square root on both sides. So P naught minus P over P naught is equal to 1 over root 2. This one cancel off. So 1 minus P over P naught. ඔහොම එකක් එනවා. මේක දන්නවනේ ගන්න හැටිනේ. P naught you divide both sides. So P naught over P cancels off and P over P naught remains is equal to 1 over root 2. Then instead of P we can put this. 1 minus P naught minus PF 1 minus P naught minus PF into 2 divided by P naught is equal to 1 over root 2. හරි. එතකොට 2P naught 1 minus 2P naught plus 2PF හරි මෙහෙම එකක් එනවා. මේකයි කැන්සල් වෙනවා 1 over root 2. හරි. එතකොට අපිට එනවා 1 minus 2 plus 2PF over P naught. Hurry. Is equal to 1 over root 2. This is very tricky. 1 minus 2 is minus 1. यहाँ पैतरे की हम plus 1 වෙනවා. PF over P naught. 2PF over P naught is equal to minus 1. यहाँ पैतरे की हम plus 1 වෙනවා. 1 over root 2 plus 1. So you divide both sides by 2. You're going to get no space also. Ayyo. If I divide this thing, I'm going to get PF over P naught will be 1 over 2 root 2. 1 plus 2. That means 1 plus root 2. 1 plus root 2 over 1 plus root 2 over 2 root 2. 1 plus root 2 over 2 root 2, that is answer number 3. 41 answer 3. Pain at the mandanne. Pain on 1 plus root 2 over 2 root 2. Make a simplification. So this kind of question you have to do at the end of the paper. This kind of question you have to do at the end of the paper. Right. Idhar questions to people. We have to finish this today. Can I go to the next question? Take a screenshot of the board quickly, people. Take a screenshot of the board. Done. Okay. I see. I also first got it wrong, then only I corrected it. 42nd on half-life of a reaction is always independent of the initial concentration. No, sometimes it is not like that. You have seen the equations. In zero order reactions, it is dependent. In first order reactions, it is not dependent. Always dependent on the rate constant. That is correct. Half-life always depends on the rate constant. That is correct. Always independent of the order of the reaction. That is wrong. Sometimes it depends. Sometimes always it depends. Zero order නම් වෙනස් නේ. First order වෙනස්. Second order වෙනස්. Always independent of temperature. No, it is dependent on temperature. Equal to the twice of the total reaction time. No, half of the total reaction time. So that is answer number 2. 42nd one, answer number 2. 43rd one. Experiment was carried out to find the order M with respect to S2O3 2 minus of a reaction. The initial rate of the reaction R was measured by adding different volumes V of 0.01 mole per cubic decimeter. So 0.01 multiplied by simple V divided by total volume. To the power M. R is proportional to this one. R is proportional to this one. Can 0.01 is a constant. 0.01 is a constant. So we can write R is proportional to V over V M. Answer is answer number 1. Okay, lazy. Just this one. Answer number 1. This is the added volume. This is the concentration. Make it total volume. This is the concentration of the total mixture. The 0.1 times 0.01 times V divided by V is the capital. This capital V is the total concentration of the mixture after dissolving. 44th one, temperature must be maintained at a constant value during the experimental determination of order of elementary reaction because order of the reaction depends on temperature. Very wrong. Activation energy changes with temperature. Very wrong. The mechanism of the reaction, no. Answer number 5. 44th one, answer number 5. තුනම පොට්ට වැරදි. හරි mechanism changes with temperature කියනවා. හරිද? order changes with temperature. Activation energy changes with temperature. If you get this wrong, people don't come home. You can make exam එකට ඇවිල්ලා මේ වගේ question එකක් වැරදුනොත් don't come to my class again. හරිද? I ඉන්දපා කතා කරන්නත් එපා. Don't talk to me again. If you get this question wrong, හරිද? Rate constant changes with temperature. That is correct. Rate constant changes with two things, the catalyst and temperature, both of them. But not equilibrium constant. Equilibrium constant doesn't change with catalyst. It only changes with temperature. 45th one. Cyclopropane goes to propene. It's an elementary reaction. Half-life of the reaction depends on cyclopropane concentration. Now cyclopropane to propene is a cyclopropane කියන්නේ මොකද්ද? මේකනේ. Met et prop. This is cyclopropane. Propene කියන්නේත් ඒ වගේම එකක් නේ එන්නේ. ඒතකොට stoichiometry එක එකයිනේ. Stoichiometry is 1. So it's a first order reaction. In first order reaction it is 0.693 divided by K නේද? Half life. So it doesn't depend on the cyclopropane concentration. It does not depend on the cyclopropane concentration. That is wrong. Rate of the reaction does not depend on the propane concentration. Rate of the reaction depends on the propane concentration because the order is 1. Fraction of cyclopropane molecules having energy greater than the activation energy increases with increase in temperature. ඒක හරි. Temperature වැඩි කරද්දී මොකද වෙන්නේ? Energy එක වැඩි වෙනවා. Energy එක වැඩි වෙනත් එක්කම මේ speed එක වැඩි වෙනවා. Kinetic energy of molecules increases. එතකොට ඒක හරි. C is correct. A wrong, B wrong, C correct. D, reaction occurs via bimolecular collision. Reaction occurs via bimolecular collision. No, neither. It's a unimolecular collision. Unimolecular collision නේ කැඩෙනවා වගේ එකක් නෙවෙන්නේ මෙතන. Propene කියන්නේ මේක. හරිද? This is propene. CH3CH CH2. Make a propene. Make a cyclopropane. Eතකොට there is like එහෙම වැළුවොත් ඉතින් hydrogen ගානත් එකයි. It's just breaking up නේද? See 1 2 3 1 2 3 4 5 6 1 2 3 4 5 6 6 hydrogens 3 carbons, nothing changes, only the orientation changes. It's not a bimolecular reaction. It's not a bimolecular reaction. We can't take it like that. Molecularity is 1 here. Molecularity is 1 here. That is wrong. Answer, I will take it as, so A is wrong, B is also wrong. It depends on propene concentration. Then C is correct, D is wrong. Answer number 5. 45th one, answer 5. 5 more MCQs remaining. 46th one. 46th one. Reaction at equilibrium can be driven forward by adding a catalyst. Reaction at equilibrium can be driven forward by adding a catalyst. No, that is wrong. Catalyst provides a pathway with low activation energy only to the forward reaction. No, that is also wrong. Both forward and reverse reaction. Answer number 5. 47th one. Mixture of A and D was introduced into a rigid container at a constant temperature T. At a temperature T. At this temperature, both A and D decompose according to the elementary reactions given below. 2A gas goes to B gas and then C3C gas, rate constant K1. D gas goes to B gas and 2C gas. The initial pressure of the container P is changed to 2.7 P. After complete decomposition of both reactants, the initial rate of decomposition of A gas at this temperature is. අපිට ලියන්න පුළුවන් නේද දැන් මේකේ according to the elementary reactions නේ. Both A and D are there. A තියනවා D තියනවා. හරිද? At this temperature, both elementary reactions given below. Okay. The initial pressure of the container is P. So 2A gas goes to B gas and then 3C gas. Meanwhile, D gas also goes to B gas plus 2C gas. Hari? Initial pressure is P. Rate constant K1 of the above reaction is given. එතකොට D gas කියන්නේ වෙනම එකක්. එතකොට D gas උත් කැඩිලා හැදෙන්නේ B gas වේ 2C gas වේ. See? Both are forming B and C. එතකොට after complete decomposition people only B and C are available in the mixture. හරි? Initial pressure එක අපි දාමු P කියලානේ දෙන්නේ. හරිද? මෙයා P දැම්මොත් එහෙම නෑ total නේ P කියන්නේ. එතකොට අපිට දාන්න වෙනවා mixture of A and D. Total final එකක් දීලා තියෙනවා නේ. මේක නම් nothing නේ, initially nothing. Let's say the pressure of D gas is Px. Partial pressure of D gas is Px. Then partial pressure of A gas will be P minus Px. හරිද? P minus Px. So amount decomposed here, I'll put it as minus P naught. Then this is plus P naught. Then this is plus 2P naught. This is plus 2P naught. Px minus P naught will be this one P naught and this one 2P naught. Here, I'll say PA. This one is plus PA over 2. This one is plus 3PA over 2 plus 3PA over 2. Oh my god, it's going to be complex. P minus PX minus PA. This one PA over 2. This one is 3PA over 2. Let's see. This one plus 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 this one will be 2.7P. P minus Px minus PA plus PA over 2 plus 3PA over 2 plus Px minus P naught plus P naught plus 2P naught. all thing will be equal to 2.7 p. So minus px plus px cancel, minus p naught plus p naught cancel. This p will go to the other side, so 1.7 p will be equal to this one 3, and this one will be 4 over 2, then this one will be 2 pa, this one will be pa, then pa plus 2 p naught. Hurry. pa plus 2 p naught. pa plus 2 p naught. They're asking the initial rate of decomposition of a gas at this temperature. Something is not adding up. කරා හරි නේද? මේක cancel වෙනවනේ. PA plus 2P naught එක එනවා. At this temperature, both A gas and D gas decompose according to the elementary reactions given below. The initial pressure of the container P changed to 2.7 P. Okay. Hurry. After complete decomposition of both reactants. After complete decomposition. After complete decomposition, then the question becomes easy. Look, everything is going to react. That means it is going to be easy. That single word, complete decomposition, is important. Look, everything will react. Minus px then. Minus px, this is plus px. This is plus 2px. So nothing, D won't remain. Then this is px, this is 2px. Then this one, p minus px ne. Hare, p minus px ne. එතකොට මේකේ ඔක්කොම ටික රියැක්ට් කරනවා. minus p minus px. Everything will react. I'll make a plus p minus px divided by 2. This one is plus 3p minus px divided by 2. Plus 3px minus plus 3p minus px over 2. මේ ටික ඔක්කොම ඇඩ් කරාම මේක බිඳුවයිනේ. මේක මෙහෙම එනවා, මේක මෙහෙම එනවා. මේකත් අවුලක් නැහැ. හරි. So we can add these things up. P minus px over 2 plus 3p minus px over 2 plus px plus 2px equals 2.7p. This one, we can add them together. So that is 2p minus px, 2 times p minus px plus 3px will be 2.7p. This one will be 2p minus 2px plus 3px will be 2.7p. This one will be px then. Px will be equal to 2.7p minus 2p, 0.7p. 0.7p divided by 2. Divided by 2 එකක් එන්න 0.7p. හරි 0.7p. Px will be 0.7p. Make a half at 0.7p, right? Then they're asking the rate will be equal to what? එතකොට instead of concentration now මෙතන මම assume කරලානේ ගත්තේ. මෙතන මම pressures assume කරලා ගත්තේ. එතකොට ඔකට ලියන්න පුළුවන් 0.7p නේ. දැන් මෙතන pressure එක මොකද්ද? P minus px නේ. P minus px කියන්නේ initial pressure එක කීයද? 2.7. 2.7 minus 0.7 is 2. හරිද? එතකොට මේක ලියන්න බලමු අපිට මෙහෙම. Rate is equal to R equals K times concentration of A squared. So R becomes equal to K times P equals CRT, C equal P over RT. So pressure of A will be P minus Px. That will be 2P. That will be 2P. 2.7 That will be 2p. හරි නේද people? RT squared. තොර 4 කියලා නේ ඉන්නේ. මොකද්ද වැරද්ද? මොකද්ද වැරද්ද? මොකද්ද වැරද්ද? මේකේ ටෙම්පරේචර්ස් වෙනස් වෙන්නෙත් නෑ නේද? What? Previous equation එක time t for time t. Time t එකට පස්සේ කොච්චරද? In that not everything will decompose, but in here everything will decompose as they say. See, both A and D decompose according to the elementary reactions given. එතකොට මේ ඔක්කොම ටික decompose වෙනවා minus p minus px. මේක බිඳුවයි. එතකොට p minus px over 2 plus 3p minus px over 2. එතකොට මේකයි 3 plus 1 4. 4 over 2. එතකොට 2p minus px plus 2px plus px is 3px. 3px is equal to 2.7p. එතකොට මේක 2p minus 2px plus 3px is equal to 2.7p. Then this one will be 2p minus 2p minus px. 2p minus px. 2p plus px will be 2.7p. So it is px equals 0.7p. px equals 2.7 0.7p. එතකොට අපිට මේක හොයන්න පුළුවන්නේ. The pressure of A initially something is not adding up. Let's do it again. I करूँ. This kind of questions I told you have to do at the end. මේවගේ උත්තර එන්නේ නැහැ වෙලාවකට. ඊට පස්සේ you are getting panicked. You're wasting time on it, right? So you have to be very careful when you're doing this kind of questions. So 2A gas goes to B gas plus 3C gas. Initial pressure is P. So I'll put this one as Px this time. Pressure of A gas is Px. එතකොට I'll say this one is Px over 2 plus Px over 2. This one will be 3Px over 2. This is minus Px. Then everything will react. මේ දෙන්න ඉතුරු වෙනවා. Then I can write for the other one. D gas goes to B gas plus C gas. Right? D gas plus C gas. 2C gas. Then I can write P minus Px. Ne? P minus Px. P කියන්නේ කීයද? 2. P කියන්නේ P නේ. හරිද? P minus Px. එතකොට මේක minus P minus Px plus P minus Px plus P minus Px මේක plus 2P minus Px. Oh my god. මේ තුනම add කරන්න ඕනේ. Px over 2 plus 3Px over 2 plus 3P minus Px will be 2.7P. මේකයි එතකොට 2Px plus 3P minus 3Px. Now only you are getting an answer, right? 2.7P. This one will be 3P minus Px. Will be 2.7P. Now okay. Px is equal to 0.3P. Then hurry. Px equals 0.3P. That means now you can apply into this equation. R equals K times concentration of A squared. So 0.3 squared. 0.3 squared is 0.09. That is answer number 3. 47th one, answer number 3. 47th one, answer number 3. Hurry. 47th one, answer number 3. මේක බලන්න මේ රෙකෝඩින් එක බලන්න පොඩ්ඩක්. තේරුම් නැත්නම් කියන්න. 48th one. Activation energy of an elementary reaction is EA. This reaction is catalyzed by the metal M. The energy diagram of the catalyzed reaction is given below. Which of the following is always correct with regard to this reaction? Always correct කියන්නේ EA is less than E1. What is EA? EA is the activation energy of the reaction. Total reaction. Activation energy is the total reaction. The total reaction less than E1. It is always larger than E1. That is wrong. EA is equal to E1 plus E2 plus E3 minus delta H1. එකත් වැරදි. Third one. EA is less than E1. No. Fourth one. EA is larger than E1 plus E2. Eighth, nah. EA is larger than E1 plus E2. Fifth one, EA is larger than delta H1 plus E1. මේකේ මොකක් හරි අවුලක් තියෙනවා මේ. Wait, I'll look at the original question. The graph looks a bit different as I remember. 2019. ලොකු අවුලකුත් නෑ. Activation energy of the elementary reaction A goes to B is EA. This reaction is catalyzed by metal M. The energy diagram of the catalyzed reaction. Catalyzed reaction they're asking. Okay. Now okay. Which of the following statements is always correct with regard to this reaction? EA is less than E1. No. No, EA should be larger than that. Right? So EA is equal to D1. එකත් වැරදි. Third one, EA is less than. No. That can't be. EA is larger than E1 plus E2. EA is larger than E1 plus E2 කියන්නත් බෑ people. You cannot tell like that. හරිද? ඒක එහෙම කියන්නත් බෑ. Delta H1 is the enthalpy of the reaction. EA is larger than delta H1 plus E2. That looks interesting. That is 27th one, right? මෙහෙමනේ. දැන් මේකේ E1 එකයි E2 එකයි කියන්නේ මේ දෙන්නමනේ. EA can be somewhere here නේ. EA is always higher නේ. Catalyzed reaction එක අඩු වෙන්න බෑ total EA එක මෙතන. හරිද? ඒක අඩු වෙන්න බෑ. එතකොට මේකයි එකතු කරාම උඩ යන්න පුළුවන් නේ people. They are asking which of the following is always correct. ඒතර always correct කියද්දි මේ delta H1 එකත් එක්ක මේ E2 එක එකතු කරාම එන්නේ මේ total addition එකනේ see. From here to here නේ. If you can see පේනවද? From here to here this addition this is E1 plus delta H1 EA is going above that like this. EA is going on top of that. That means it is always correct. 48th one, I'll take it as answer number 5 then. I'll take it as answer number 5. Last two MCQs. If P plus Q goes to R is a first order reaction with respect to reactant P, the graph of the rate against concentration of P gives a straight line passing through origin. That is correct. It's a first order reaction, then it goes like this. Initial rate of a first order reaction is independent of the concentration of reactant. Initial rate of a first order reaction is independent of the concentration of reactants. No. That is wrong. Initial rate of a first order reaction is dependent on the initial concentration, right? Because it's first order. That is wrong. First is correct, second is wrong. Answer number 3. 49th on answer number 3. 50th one. Reaction C2H4 plus 3O2 goes to 2CO2 plus 2H2O gas. occurs in a rigid closed container at a constant at a given temperature. After a certain time, it was found that the rate of the reaction with respect to consumption of C2H4 was x mole per cubic decimeter per second. Which of the following shows the rates of consumption of O2, formation of CO2, and formation of H2? They have given consumption of C2H4. If they have given the consumption of C2H4, you just have to multiply it by the stoichiometry in order to find the others. How do? That means 3x, 2x, and 2x. Answer number 5. 50th on answer number 5. So there you go. 50 MCQs discussed in today's class. The tute is complete. Kinetics. So kinetics, normal questions we did. Kinetics MCQ discussion we did. 50 questions there. And then we have to do that kinetics and KD mixed question set we have to do. So එතනින් පස්සේ kinetics we have stopped. We are going to stop touching kinetics after that. So that's the last question set which you are doing. So next week or day after next week after next week, we'll be doing them. So yeah, that's it. If I upload this in as a free session or sometime, ඉස්සරහට මේක free session එකක් විදිහට දැම්මොත්, I'll share the PDF as a YouTube. يعني YouTube video එකේ description එකේ දාන්න link එක PDF එකේ. හරි? No, this is for the people who are watching the recording. හරිද? YouTube එක දැම්මට පස්සේ recording එක බලනවනේ. හරි. Okay then people, okay then. You can leave the meeting now. Thank you for joining. Good night.